Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about AI for productivity. This topic is based on a tech blog titled How the New York Times is Scaling Unit Testing Coverage Using AI Tools, written by their engineering team. Throughout this episode, we will explore this topic from both the business and technical angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. The New York Times is one of the most visited news websites in the world. It has engineering teams that are consistently shipping new features and maintaining a large, complex code base. And like any software product, that code base requires unit tests. Think of unit tests as a safety net. You break your code into small, individual pieces and write automated checks for each one. That way, when you change something in one part of the application, you can quickly detect whether it accidentally broke something else. Strong unit test coverage means fewer surprises in production, faster releases, and a more reliable experience for readers. The problem observed was that the team's test coverage had not kept pace with their rapid development. When the team audited their main news sites, they found that only about 60% of the codebase was covered by unit tests. To compensate for that gap, engineers had to rely heavily on manual testing before releasing new features, which is time-consuming and does not scale well. Closing that gap in a traditional way is very hard. It requires having engineers manually write tests across a massive codebase, which could take weeks or even months. So the team asked a practical question: could AI handle some of this heavy lifting problem? Now that we've understood the business problem, let's shift gear and dive into the technical side to see how the team tackled this challenge. The team started with a clear goal to increase the unit test coverage across their news monorepo. This is a large shared codebase used by more than a dozen teams, and coverage was sitting at around 60%, and they want to push it to 80%. To begin with, they focused on 6 projects with especially low coverage, averaging around 28%. So how did they go about it? The step 1 was to measuring the gap. Before rating any test, the team built a small internal tool called TestConf. This tool scans directories and measured test coverage at the individual file level. That turns out to be critical because it allows the team to track progress in real time. And it also fed directly into the AI agent's workflow, so that the agent always knew exactly which files needed attention. Step 2 was designing what they called a two-loop system: the user loop and the AI loop. Here is how it works. An engineer would kick things off by starting a chat session with the AI agent and providing an initial prompt. From there, the AI loop took over. The agent would run the TestConf tool, identify gaps in coverage, generate new unit tests, execute those tests, and then measure coverage again. If the goal wasn't met, it would simply repeat the process. In the ideal stage, the engineer only needed to trigger the process once and then step back while the AI iterated toward the target. Step 3 here was putting strong guardrails in place. This is where things get especially interesting. Letting an AI agent modify code in a production environment comes with real risks. First, the agent could introduce bugs or even security issues. Second, it might cheat by modifying the source code to make tests pass, instead of writing tests that validate real behavior. To prevent these risks, the team introduced two protective walls. The first was a strict rule in the prompt: do not modify the source code. The second was the test cough tool itself, which generated a read-only coverage report that the agent couldn't manipulate. Together, these constraints created a controlled environment where the only way to succeed was by writing valid and meaningful tests. Of course, the process wasn't completely smooth, and the team learned a few important lessons along the way. The first lesson was about prompt engineering. Early prompt was messy. The agent would hallucinate commands, get stuck in repetitive loops, and run into context limits. To fix this problem, the team invested heavily in refining the prompt. They ended up with a detailed 7-page instruction guide, which is initially drafted by AI but carefully reviewed by humans. And that guide clearly defines the agent's role, testing conventions, and safety rules. For example, it includes instructions like stop after 10 iterations and never modify the source code. The second lesson here was something they called context rot. When too much information was fed into the model, like full directory structures or large document sets, the performance actually got worse. The agent became distracted, used the wrong tools, or even hallucinated information and then reinforced its own mistakes. The solution here was to keep the context lean and focused. By limiting each run to a smaller scope, the agent performed better, and the resulting code changes were smaller enough for engineers to review effectively. And the end results were impressive. By the end of this project, test coverage had reached to 83%. The team also estimated that AI reduced the required effort by about 70%, turns what would have taken weeks into just a few days of effort. This is a strong example of how the AI, when paired with the right system design and guardrails, can significantly boost engineering productivity. Now that we've discussed both the business problem and technical solution, let's wrap it up. In this episode, we explored how the NYTimes engineering team used AI agents to scale unit test coverage across their news site. They accomplished this by building a custom coverage measurement tool, designing a two-loop human-AI workflow, and investing heavily in prompt engineering, including strict guardrails to prevent the agent from cheating or drifting. The key takeaway isn't simply that AI can write tests. It's that AI works best when it's tightly constrained, carefully monitored, and used to amplify human judgment rather than replace it. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.